Good morning everybody. In this video we are going to see about spectroscopic techniques, especially UV visible spectroscopy. In UV visible spectroscopy we are going to see about its principle, instrumentation, advantages and disadvantages of using UV visible spectroscopy. Spectroscopic techniques. So generally what is meant by spectroscopy? It is a branch of science that deals with the interaction of electromagnetic radiation, popularly called as EMR, with atoms or molecules to study their composition, structure, and properties. So, by using those analytical techniques, we are able to do all kind of studies such as the molecules composition, structure, and properties. So, researchers are keenly used these analytical techniques in order to review their synthesized materials. So, what is meant by UV visible spectroscopy? So, the principle deals with the absorption of UV light or visible light by its chemical compounds. It means the prepared chemical compounds, in which it results in the production of some distinct spectra. When atoms or molecules absorbs the UV light, it undergoes some excitation. This causes jump from ground to excited state. It means electrons. So it is very important to note that the difference in the energies of the ground state and excited state of the electrons is always equal to the amount of light. It means the amount of UV light or visible UV or visible radiation energy absorbed by it. So it is very clear that it is deals with excitation of electrons. So generally each and every atoms or molecules deals with that. Based on that, how it confirms the presence of those uh, atoms or molecules in what state, etc., would be analyzed through mainly the excitation of electrons. It will happens when the energy is getting absorbed. Okay, so this is the instrumentation picture that we can viewed from the PowerPoint slide. So it shows that UV visible 50 to 400 nanometer range and visible 400 to 800 nanometer range. So sigma to sigma star excitation, pi to pi star excitation, n to sigma star, n to pi star. These are some of the versatile excitations of electrons. Example, methane for sigma to sigma star and pi to pi star, CH to CH2, OH for N to sigma star, and N to pi star, C double bond or carbonyl based organic compounds. So as we already discussed in that instrumentation picture itself, it deals with electronic excitations that we are shown here. And what are all the functional groups present in that material, it clearly denotes. So based on that atomic and molecular interactions of the materials, it denotes. So to study the chemical properties, the concentrations, so some unknown compounds which are newly supposed to be prepared, or researchers prepared some new compounds, they are also made with the preliminary confirmation through UV visible spectroscopy. And their physical electronic structures of synthesized organic and inorganic compounds are made through UV and visible spectroscopy analytical techniques. So some of the examples here shown are materials. What are all the materials? So metal nanoparticle material, metal oxide nanoparticle material, magnetic metal oxide nanoparticles, and especially polymers also. Metal nanoparticle material, for example, basically we are showing you the examples are silver, gold, copper nanoparticles that researchers mainly In day-to-day life, researchers are using those nanomaterials. And metal oxide nanoparticles, we know very well about oxide based AgO, TiO2, SiO2, etc. And magnetic metal based oxide nanoparticles, Fe3O4. It is having magnetic property. So here, cobalt ferrite also there. These magnetic metal oxide nanoparticles are also confirmed in a preliminary test through UV visible spectroscopic analytical techniques. And polymers also, especially conducting polymers, since there is a conjugation. That's why we are showing here example polyaniline. It's also confirmed through UV visible spectroscopy. Then later they will go through higher spectra techniques or higher application technique, etc. Preliminarily, they can make an initial confirmation. That's why we used to tell that preliminary test through UV visible spectroscopy. So some spectrum. So one example we are shown here is silver nanoparticle spectrum, UV spectrum. Okay, generally deals with absorbance, confirms at 422 nanometer. That peak shows. It means metal silver nanoparticles is confirmed. So what are all generally advantages and disadvantages of UV visible spectroscopy? So quantitative analysis. It means how much. So concentration. We are using those nanoparticles in the solvent material. It would be analyzed through UV visible analytical techniques, and it is very fast and facile. It means speed. We can take a rapidly the confirmation analysis, and handling is very simple. Actually, simple test can learn easily the techniques. It's not like complicated like high tech um, technique applications, etc. It's high tech instrument, etc. It's very easy to learn also. The basic researchers can learn this technique and he can handle without any mistake. That's why it shows speed and simple, and it is very less cost compared to other big techniques. That's why cost effective and non destructive. That is very familiar, versatile. We can go all compounds, the prepared materials, metal, magnetic, metal oxides, nano based material through UV. And the quality also, it will give the particular information about the quality. So what are all the materials exactly it present, how much it present, etc. Quality, the presence any impurities is also there, yeah, it will clearly denotes. And limited specificity, some of the disadvantages are limited specific. It means only works for molecules with chromophores. So some double bond based compounds is there, some electron dependent, those compound can be viewed exactly. So some of the disadvantages are there. So mixtures complexity, it means that some of the you know, some special overlap in mixtures, it makes it difficult, some complicated issues also there. And also suspended particles means, yes, there will be some turbidity is there. uh, it is difficult to analysis. The analysis can be carried out, but it will show some error also. So these are all some of the disadvantages. And the sample preparation, we have to be very careful. That's why it shows that need more preparation of the sample. Cuvettes should be very clean. So if there is any small impurity, yes, it will be sensitive to those impurities. It may give some extra peak also. That's why it shows some disadvantages here. So these are some of the advantages and disadvantages of UV visible. But overall concern, UV visible has have more advantages, since cost effective, uh, measurement friendly, so that researchers can easily handle and they can make the preliminary confirmation. So it is very important to review about UV visible spectroscopy. So thank you so much.